So hi everyone, I am Arun from SNS College of Technology. In this video I am going to share about DT based modern control systems. Normally the control systems are based on open loop and closed loop systems. Especially for sensor applications we are using this control systems. In order to achieve more number of sensors application, we can use this control systems. For example, we can use car control applications for a lot of control system process, because in car control systems there are two way of communication. One is open loop and another one is closed loop. Open loop is a stable one because it is a one kind of application we can able to perform in a car scenario. At the same time we can use multiple number of operation at the same time, means we can use closed loop system. So commonly we can have a modern loop control systems. So let us consider how the modern loop system has been enabled by using this DT frame.
A modern control system refers to a sophisticated approach to controlling dynamic systems, integrating advanced computational tools, design methodologies, and feedback mechanisms. These systems aim to ensure the desired performance of machine process and the system while adapting to changing environment and uncertainties. Sensors and transducers measure such parameters as temperature, pressure, or velocity. Controllers compute control action based on design and measured system states. Actuators execute the control command to influence the system's behavior. Communication network enable data exchange between system components in real time. Digital computing units perform real-time calculation and implement control algorithms.
So now we are going to give a solution based on the DT framework. There are 5 steps in DT: empathy, define, ideate, prototype, and testing. So the first step is empathy. In the empathy we are using the define the system and in components, formulate the mathematical model and list the necessary equation, write the differential equation describing the model, solve the equation for the desired output variables, examine the solution and assumption. If necessary, we can reanalyze and redesign the system.
So in define part, we are going to see the working model of a solution. So here we are using armature with RG component, and inertia as J and friction as B. And next we are using a started winding machine in which it consists of a rotor and a stator, and it has brushes and bearings. And it also consists of a commutator to control it. We have a feedback loop, so if we find any error on it, we could rectify the error by using this feedback loop. So this is about define. So in ideate we get the entire ideology of the problem statement. So first we need to find the control goals. And with that we need to fix the variables which is need to control the entire system, and we need to find the specifications for those variables. Then we need to establish a system configuration with those variables, and in order to make the model process, we need to decide the actuators and sensors, and we use various key parameters which act as a controller to the system. So by this the performance will undergo, and if there is any error in the performance, the iteration will occur. If there is no error, the process will stop, and we can finalize the design.
Here in this prototype model, we have the feed water, fuel, air, which is given as an input through the valve. The valve is connected in between the input and the boiler. From the boiler, it is sent to the turbine. From the turbine, it is sent to the shaft, and generator is used to generate the specific electricity. And the computer is used to give the input information through the software. And the temperature measurement is used to measure the temperature of the particular machine, and the pressure is used to reduce the pressure or increase the pressure based on the current status.
So to test the prototype is mandatory. In the testing part, the input signal is sent to the error detector, and the error is detected and sent to the controller, and the actuating signal is produced by the controller, which is given to the feedback, which corrects the error. So after detecting the error and the process is sent to the controller, and the servo mechanism is activated, and again the feedback loop is activated. So and the measuring device and the output is produced by the indicator.
So as a conclusion, modern control systems are concerned of technology's advancements, enabling efficient and reliable operations of various industries and applications. There are factors that helps the modern control systems, which are integration of technology. They incorporate digital computing, sensors, actuators, and communication networks for sufficient operations. Then feedback mechanism. Feedback mechanism utilizes the loop to minimize the errors and maintain desired output levels despite disturbance. Then model-based designs employ mathematical models to simulate and predict and optimize the system behavior. Then the last one is the automation. They are widely used in automotive systems requiring minimum human intervention.